Thank you for joining our session. My name is Laura Kahn, and today my colleague and I, Terry Walker, will be presenting a responsible artificial intelligence perspective that considers a spectrum of possibilities for defense. I'm a data scientist in the applied intelligence practice at Accenture Federal Service, with research interest in academic papers in responsible AI and 2 patent applications in humanitarian logistics. I'm currently supporting a defense client to ensure a more efficient data-driven organization with graph analytics. Prior to joining Accenture, I held a variety of IT management and intellectual property roles at the U.S. Patent and Trademark Office. I hold a master's in data science from Indiana University, a bachelor's of science in textile engineering, and a bachelor of arts in Spanish from North Carolina State University. In my spare time, I attempt to grow tropical plants such as coffee on my patio in Northern Virginia. At this time, I'll hand it off to Terry for her introduction.
Thanks, Laura, and good morning. I'm Terry Walker. I'm also a data scientist at Accenture Federal Services Analytic and AI practice. I currently support a defense client building advanced analytic techniques in order to derive insights and trends within publicly available information. My background is largely based in IT systems, architecture engineering, and defense cyber operations. I've served more than 20 years in the Army National Guard, and for my day job, I previously worked in a variety of positions within our cyber. I hold a master's in computer and information system security from Wilmington University and a bachelor's in computer and information system security from UMUC. In my spare time, I'm also a certified dive master, and I enjoy swimming with sharks for fun.
Thanks, Terry. Ensuring that the acquisition, design, development, and use of AI is done in a manner that protects privacy, promotes civil liberties and civil rights, and is consistent with American values is top of mind in the Department of Defense. Everyone can agree we need AI and data for mission advantage, but what does that mean? Unlike traditionally technology-focused AI approaches, we consider data in context with people, since people are not only using technology such as AI, but are increasingly affected by it. AI brings unprecedented opportunities, but also an incredible responsibility. The output from AI systems has a real bearing on people's lives, raising considerable questions around AI ethics, data governance, trust, and legality. The more decisions put into the hands of artificial intelligence, the more risks, such as reputational, employment or HR-related, privacy, health, and even safety issues. The use of AI and collection of data sets have unique requirements in the Department of Defense. Machine learning models can help improve quality of life, reduce bottlenecks, and guide decision-making. Just as there is a spectrum of ethical decisions varying by use cases, there is a spectrum of possibilities in how to implement responsible AI at the tactical and technical level. Today, we'll be focused on a narrow subset of responsible AI, the technical level of supervised machine learning models. We are focused on supervised machine learning because it makes up most of the federal use cases we have seen in 2021. However, there are other ways to consider post hoc unsupervised machine learning, like Accenture's algorithmic fairness tool, or organizational implications we explore in workshops or with our impact assessment metrics. Next, please turn your attention to an introductory video on responsible AI.
What is responsible AI? Imagine you're driving down the freeway. There's a slowdown up ahead, so you slow down. But what about after it clears up? Will you stay at a slow speed just in case at some point traffic slows down again? Of course not. You'll drive fast again, knowing that if you need to use the brakes, you will. Those brakes do for your car what responsible AI does for your business. It lets companies implement AI at scale with confidence. Knowing responsible AI can help avoid problems up ahead or even course correct, all by making transparent, trustworthy decisions. Companies using AI to help identify and recruit candidates run the risk of perpetuating inherent biases in the data, drawing on practices that might have skewed to one group or another in the past. But responsible AI can help them recruit and consider a broader pool of qualified candidates. We hope this was a fair representation of responsible AI.
Recognizing the strategic importance of AI to the nation's future economy and security, the 45th administration established the American AI Initiative via Executive Order 13859 in February of 2019. This initiative identified 5 key lines of effort, including increasing AI research investment, unleashing federal AI computing and data resources, setting AI technical standards, building America's AI workforce, and engaging with our international allies. The National AI Initiative Act of 2020 codified these lines of effort. In America, we believe it's our duty to act with honor. We owe it to the American people to put our shoulders to the grindstone, as Secretary Hicks said Tuesday, and deploy responsible AI at the speed of relevance, not just on the physical battlefield, but on the battlefield of the world of data. Additionally, there have been DoD memos on creating data advantage, also known as the 5 tenets, from May of 2021, data ethics oversight from December of 2020, and most recently, implementing responsible AI and ethical principles memo in May of 2021. The responsible use of data and artificial intelligence is not only a mandate as per the executive order and memos, but is critical to the DoD's mission writ large. Accenture defines responsible AI as the practice of using AI with good intention to empower employees and businesses and fairly impact customers and society, which in turn engenders trust. Today, we're going to talk about our responsible AI framework. The 4 components of our framework are fairness, performance, auditability, and training. Although we are focused primarily on the technical pillar at the machine learning model level in our framework, we recognize this is just the tip of the iceberg and one piece of the responsible AI puzzle. Other legal frameworks and techniques will be needed to accommodate the complexity of acquiring, designing, developing, and using AI for defense applications. The first component of our framework is fairness, and it asks the question if the model outcomes are independent of sensitive variables. Sensitive variables might include, but are not limited to, those that are protected under equal employment laws, such as race and gender. How do we protect all members of society in a manner consistent with American values and the law? The second component is performance. Using historical data, are we confident in our model outcomes, and does our weapon, data, perform as intended? Our responsible AI framework helps fulfill a mandate and can also improve model performance. A lot of people don't think about the relationship between improving performance and responsible AI, but we think that adapting a performance component in the framework moves the responsible AI conversation past just an ethical one to meet U.S. federal government's mandate to be fiscally responsible, to use taxpayer money wisely, serve citizens, and meet the mission more efficiently and effectively. The third component, auditability. How do analysts update or account for new changes in a model? Suppose there's a new event that's occurred. For example, we've used web scraping to determine a new event. How do we update the model? It's easier to audit when you have proper documentation and a human in the loop throughout the data science lifecycle. Just as machine learning operations accounts for drifts in data with human oversight, auditability for responsible AI is a guardrail for changing models. And finally, training. People across the defense enterprise must be trained on how to interact with data and AI. Once there's a standard set of procedures or steps according to an organization's needs, the training needs to become a natural part of business processes and the broader culture. Our 4 components of fairness, performance, auditability, and training complement the DoD AI ethical principles, as I will discuss in the next slide. Each of the DoD ethical principles of responsible, equitable, traceable, reliable, and governable map directly to Accenture's framework's components of fairness, performance, auditability, and training. For example, when Accenture says we want the model to perform as intended, what we're really ensuring is that there's quality of the algorithm. Responsible, equitable, traceable, reliable, and governable. Without meeting thresholds in any one of these areas, the model would fail in the category of performance. We've already said that machine learning is like a weapon. How many of you have backgrounds as a program executive officer? If you're a product manager at PEO Soldier, responsible for individual and crew-served weapons, what does performance mean to you in that context? Well, you're going to make sure the weapon system works correctly. It must shoot straight. There are .mlpf considerations, such as who will have the access, authority, and training to use the system. At the end of the day, a developmental machine learning algorithm needs to uphold similar equitable standards. Besides performance quality, there must be associated governance established and thorough training for end users at the technical level. As we look to the bottom of the matrix, training also maps to all DoD principles. Machine learning deployment standardization is critical, and we establish this through documentation and training. Any person who touches the model must be able to follow a repeatable and standardized approach. Accenture's framework helps the developer ensure they are building DoD's stated ethical principles into each capability. Together, these components as a system build trust, ensure privacy, and serve as a guiding set of principles for AI practitioners. At the end of the day, implementing responsible AI is about determining boundaries along a spectrum of possibilities. Boundaries are not hard and fast rules across all AI implementations, but need to be constantly adapted depending on the organization, specific context, and people affected by the algorithmic decisions. The responsible AI framework is not just about minimizing risk and being legally compliant and financially accountable, but also can minimize bias that humans transfer into the machine learning models, improve decision-making capabilities, and increase model performance. While AI is well suited to support strategic decision-making and data-driven recommendations, human input and oversight is ultimately required to maintain accuracy and trustworthiness. Accenture effectively manages the interface and handover between people and machine through a human AI feedback loop that incorporates user-derived corrections to minimize risk and increase model performance. Human oversight is critical in deploying AI. Humans should periodically review AI decisions and subject them to performance reviews, just like their human counterparts receive. Oversight helps AI decisions remain compliant and serve as useful checks when decision criteria are changed via legislation, for example. Responsible AI helps fill voids in explainable machine learning models by focusing on the handoff from AI systems to humans, ensuring that frontline staff have the insight needed to act on ambiguous data and sometimes ambiguous results from models. The goal of our framework is to minimize risk for black box decision-making and increase transparency and performance. It specifically addresses technical components as part of broader considerations for responsible AI. There's a common misconception when it comes to responsible AI. A technical team says that if there's documentation, we have success. Or they may go a step further and more stringently apply standards of explainable AI models. This is a start in the right direction, but your responsibility is not over. If any of you have watched the movie Terminator, you may recall Skynet. Just because you can explain how Skynet works, you still may not want it making certain decisions that will affect your life. So, if documentation alone isn't enough, how do we build confidence in the AI-based technologies we're developing? How might we intentionally design more altruistic AI in the world we're creating? Are we asking the right questions? And who gets to decide? Since supervised machine learning models are the focus of today's talk and rely on labeled input data, practitioners need to focus on creating labeled data sets with all people in mind. There are at least 4 ways to improve labeling: active learning, random sampling, preference filtering, and inter-annotator agreement. In active learning, the model chooses the data points it's most uncertain about that are close to a decision boundary. In random sampling, data points are selected at random. In preference filtering, data points are selected based on user preferences, such as recommender systems that use profiling to personalize user interfaces. Finally, inter-annotator agreement focuses on labeling techniques and discrepancies between 2 or more human annotators. Towards the end of the presentation, we'll talk about ways Accenture's expertise in labeling was recognized internationally. Now that I've talked about labeling for supervised machine learning models, I'm going to turn it over to Terry to talk about other ways humans introduce bias and what to do about it.
Thanks, Laura. Human transfer bias is, simply put, the transfer of an individual's preconceived or unconscious opinion. That bias gets transferred from the human to the model as we manually tag data. As we've just said, our model is trained and learns from the sample data. If the sample data is biased, then the outputs of the model cannot be trusted. As depicted in the lower left image, iterated bias affects model outputs and ultimately performance. The question is, what do we do about it? We must baseline the human labeling system. This means humans must be consistent with their tagging approach during the data annotation phase. Without this consistency, consumers can lose trust in the model's outputs. So, how might we improve the system? We can develop solutions with meaningful interactions with subject matter experts. We must pair available labeling software with service integrators who understand the domain, system, and algorithms. Then we must develop both annotation guidelines and inter-annotator agreement standards. This is the measure of how well multiple annotators can make the same annotation decision for a certain category. It shows how clear your annotation guidelines are and how uniformly your annotators understood it, and how reproducible the annotation task is regardless of who's annotating. It's a vital part of the machine learning results. Let's take a look at the example in the middle. The image represents a network graph developed back in 2014 for the J39. Accenture collaborated with academic partners to analyze a 1 month snapshot of website forums from the CENTCOM web operations. All nodes represent an online forum. The edges are the number of actors who visited the forum. Red is pro Al Qaeda, green is pro America, and yellow is unassessed. As analysts developed the network diagram, they used a random sampling method, but did not have deliberate labeling standards to ensure appropriate named areas of interest. The initial machine algorithm yielded 64% precision, and ultimately, the customer requested additional manual tagging to ensure quality and a lower recall rate. After rerunning the assessment, the model yielded a 64% precision rate, but at a cost of $4 million for human annotators. So, what can we learn from this? By standardizing labeling upfront during the annotation phase, we could have we could have ensured trust and potentially saved $4 million in labor costs. While AI is well suited to support strategic decision making and data driven recommendations, human input and oversight are ultimately required to maintain accuracy and trustworthiness. Humans excel at nuance and the context needed to support defense decisions. Accenture effectively manages the interface and handover between people and machines through a human AI feedback loop that incorporates user derived corrections to improve model performance and reduce risk. However, there's no one size fits all approach. Humans should periodically review AI decisions and subject them to performance reviews, just like their human counterparts. And these reviews must be tailored to specific conditions of each use case. Performance reviews are particularly needed when decision criteria are changed. For example, new legislation would generate a need for a performance review. So let's put our responsible AI methodology to work in a notional use case. Let's say Atlantis took military action against its neighbor Westeros last week. They have to be prepared for what will happen next. They need to understand the likely Westeros response both before and after the military action. Atlantis must stay informed, leveraging PAI in near real time to maintain the operational or competitive edge over Westeros. So let's frame the problem. After the attack, bad actors in Westeros began a social media propaganda campaign against Atlantis. As insidious as a direct military attack, misinformation spread by bad or unwitting actors undermines peace by constantly eroding truth and democracy. How might we responsibly use a powerful unseen weapon, data, to inform decisions? By conducting robustness testing or Monte Carlo simulations of publicly available information and subject matter expert surveys, Atlantis can execute thousands of model runs, varying input conditions to see the resulting distribution of outcomes. On the left, we see the full range of potential Westeros responses. Initial insights might suggest a potential proxy retaliation attack, but if we look closely at the distribution of data on the graph on the left, the normal distribution falls within the range of likely diplomatic reaction, whereas the outlier was clearly a bot or a Westeros sponsored propaganda activity. Analysis of the actual militia demonstrates the government was likely leaning much closer to that diplomatic response than the bot activity suggested. The simulation ultimately reveals Westeros' response likely will be diplomatic and Atlantis can adjust accordingly. But how do we ensure that it's a valid conclusion? And how do we convince decision makers that this data is reliable? We must employ the responsible AI framework: fairness, performance, audibility, and training to overcome the human transfer bias. Let's walk through how an analyst would approach the problem using this framework. Potential human bias risks include inferring multiple meanings from sentences. Something that has a negative connotation in one language could be just informal slang. If you only have three labels to choose, and those are pro Westeros, pro Atlantis, and unassessed, you're limiting the labeling scope, because someone can be negative towards Atlantis, but still not pro Westeros. So, for example, if someone burns the Atlantis flag, it does not necessarily equate to public sentiment or support for military action. As Laura spoke about before, the four ways we introduce human bias into our models are random sampling, preference filtering, active learning, and inter-annotator agreement. That's inter, INTER. Maybe I said it too fast and you heard me say inner with two N's. That simple human misinterpretation could have a dramatic shift in model accuracy. Now, let's see the framework as the data scientist would at a 30,000-foot view. An Atlantis analyst would start by defining the requirements, operationalizing the data, conducting analysis, and then developing visualizations to support key leader decisions. Putting our RAI framework into practice, we improve fairness not just by looking at a small sample set of Westeros historical data, but we account for that historical data of Westeros over an extended period. How are other countries of similar attributes responding? And we use these techniques to mitigate discrimination and bias in our model. For auditability, Atlantis needs an annotation plan, an inter-annotation agreement, and metrics to demonstrate repeatability and consistency in data labeling. Additionally, Atlantis needs to ensure that the analysts are all properly trained and adhering to the established guidelines in data curation, and labeling. Lastly, to build in fairness and performance in our model, instead of performing a single predictive simulation, we use the robustness testing to run thousands of times, varying input conditions to see a distribution of forecasted outcomes. From the drill down image on the last slide, recall the proxy attack by the Westeros bots. By including human oversight, we could have clearly seen this result was only the outlier in the results. Let's face it, AI is complex. There's a spectrum of ethical decisions with moving boundaries depending on the use case. We can identify many problems and challenges, and it can be overwhelming to know where to start. But just for a minute, let's imagine your house is on fire. This can end in a million different ways. Your home can go up in flames, It can be contained in one room. Lighted embers could set your neighbor's house on fire. Yet we all know exactly what to do in this situation. We learned it when we were children. We may have even learned this before we could read and write. Stop, drop, and roll. And that's what we want to give you today, a simple and straightforward, responsible AI framework that can work for multiple defense use cases to get you on the right track. If you take anything away from our presentation today, it's this. A simple framework can minimize risk, increase transparency, optimize decision making, and maximize model performance. However, there's no one size fits all approach, as the framework must be tailored to each specific use case. There is a spectrum of possibilities in your responsible AI journey. Recognize when you need help and reach out to SMEs for support. Contact us for more information on Accenture's algorithmic fairness tool, responsible AI workshops, or impacts assessments. Finally, you have to train and strive for continuous improvement gains. As we all know that you train like you fight, so fight like you train. Improving labeling consistency in turn improves machine learning models, which is how we implement the performance component of our RAI framework. Accenture Federal Services is a leader in developing natural language processing techniques for business use cases. Here are some recent global competitions we've won. Don't incur technical debt, as we've talked earlier, with spending $4 million for a 4% marginal gain. We're here to help throughout the journey in a cost effective way. Thank you for your time. Here's how to get in touch with our experts on responsible AI.